Okay, well, I'm extremely happy to be here, and I enjoyed very much the discussion around Shane's talk. I'm very happy to be in an environment of very critical thinkers, and I invite that critical view. I'm going to zoom right into the form of data that I'm most fascinated with. As a computational linguist, I'm extremely interested in learning through discussion, and to zoom right in on discussion and to understand discussion better. And I'm going to illustrate for you some of what we're doing in that space and what can be done currently. But I'm definitely not going to try to convince you that it's a solved problem and that there isn't much left to do to make it better. So it's a work in progress. This is a picture I'd like you to keep in your mind throughout my talk. I'm going to focus on a very particular form of discussion. And I want you to think of it as being like the pieces of a DNA. That if you can understand some of these core aspects of communication that make it work well in a learning context, the bigger picture of learning and learning processes, both cognitive and social, are built around that and fit around that. It's important to understand what those pieces are, and I'm going to focus on a particular piece referred to as transactivity. Transactivity is a property of communication that has been named a lot of different things, but in the computer-supported collaborative learning community, we tend to refer to it as transactivity. The simple idea behind transactivity is that a transactive contribution is one in which a student articulates their reasoning, in other words, displays the mechanism that they understand is behind an idea that they're expressing, and they make a connection with that expression to some previous expression of idea or reasoning from earlier in the conversation. There are many ways of defining the space of possible transactive contributions. And one particularly famous way of breaking it down divides types of transactive discussions along three different dimensions. One is whether that transactive contribution is building on one's own reasoning or another's. One is whether it refers to that idea that was expressed earlier as is or transforms it in some way. And whether that connection is consistent with the idea as expressed earlier or challenges it in some way. These dimensions define different levels of challenge in how students engage with each other's or their own reasoning within a meaning-making encounter. And they can be associated with different levels of learning and have been effective in different learning contexts. There's a lot that we could go into in this, but I want you to have the idea of the simple concept of transactivity. The idea comes actually from the area of developmental psychology. And if we go back to the roots and think about the development of this idea over time, as it has developed within different research communities, including educational psychology, computer-supported collaborative learning, and others beyond developmental psychology where it originally came, we can see how this building block touches upon both the cognitive and the social aspects of learning, and why then it's so important to understand this building block. Because knowing the building block helps us to model conversation in a way that gets at something that's essential for the learning process. And once we can get a hold of that, we can support that, encourage that, foster that with technology. The important idea here is that these transactive exchanges represent a cognitive effort on the part of a student to evaluate both that student's own mental model as it stands and another's, which gives the opportunity to identify discrepancies and to open up to a development or shift or restructuring. It only happens when a student is open to what another student or another person, maybe not a student, or even an object in the world that a student is interacting with, has to say to them about their perspective. It requires the student to respect their own ideas, but also to respect the ideas of others. And it's because of that dynamic that it touches upon the social dimension as well. There's an important social foundation that has to be in place in order for this process that has important cognitive implications to occur. If we consider that connection, we can understand why in the series of results that I will show throughout my talk, we see that we can foster good collaborative relationships between students and that it leads to learning gains. So I have entitled my talk From Data to Design because it's important to us in our work to base the interventions that we develop on data. And that's why analytics is so important and so powerful, because it is how we can get our heads around what the data is telling us. And then we can use that data, the same models that we learn from, to trigger interventions. It's important then to be able to represent the data in a way that is effective for our modeling, to build modeling on top of the data from that infrastructure, to draw inferences, and then to use those to develop interventions, which generates then more data for us to continue our learning and development process. And I will share in the end some pointers to resources that we would be happy to share with others who are interested in joining with us in this work or applying this work in their own contexts. A lot of the work that we've done in my group is in the area of computer-supported collaborative learning, where students are working together in groups to learn about things like, in this case, thermodynamics. It could also be biology. We have applied this also in a variety of MOOC contexts, math, sciences of different age groups, engineering, and recently even a course offered by the Smithsonian Institute in the United States on superheroes, which is really actually a history course. In these collaborative contexts, students work together. They have their own client interface that you see here, attached to a server in the back end that connects them all together, that allows them to interact. And they can interact through chat, and they can pass images back and forth. And there are other forms of interaction that we've enabled in other studies. But what's important, and what might be slightly difficult to see in this picture, is that we have also built conversational agents that are computer programs that act sometimes like fellow students or sometimes like instructors. And they interact also in these groups to help to structure the activities and support the processes as they're going on. So this is a paradigm for kinds of interventions that we can build with technology. And it is important in these interventions to be able to keep tabs on how students are interacting with each other. So this is where our analytics come in and are used to support the learning processes. And we have a series of published results that show that when we offer this support, we get significant improvements in learning. So I'm going to divide my talk into 4 steps along the way. I'm going to start with talking about how we've used this in a classroom context. This comes from a study in 9th grade biology. We worked with a school district, an urban school district in the United States that was a troubled school district. And in that district, we worked at 2 different levels. We worked with teacher professional development, and we also worked directly with students in collaborative groups. And that was to support actually the teachers. It prepared students for their discussions with the teachers. But ultimately, what we wanted to achieve was to get a better interaction going in discussion in the classroom, either in small groups or in the whole class. And we drew upon an idea for classroom facilitation that comes out of the classroom discourse literature called accountable talk. How many have ever heard of accountable talk? And I refer you to the recent book that has been published on socializing intelligence that focuses on accountable talk and other forms of facilitation and discussion like this, and recounts a variety of really impressive results that show that classrooms where teachers are able to use these practices effectively show steep improvements in achievement, retention, and transfer of learning. So what is accountable talk? It's a way that teachers come into a discussion and place student reasoning at center stage. In the classroom discourse literature, the focus has been on what teachers are doing in order to facilitate discussion and being able to really formalize that process, working with teachers to try to help them do it, and then looking at how that affects learning. Interestingly, the focus in that research community has not so much been on the DNA of the student interaction. On the other hand, if you look at what teachers are doing, prompting students to add on, asking them to agree or disagree, pressing for more reasoning, what they're really doing is trying to elicit from students this transactive interaction that in the CSCL community we focus on when we look at the discussion between students. And what we see, and interestingly, though there had not before a collaboration between my research group and Lauren Resnick's research group at the University of Pittsburgh, related to putting research from the classroom discourse community and the CSCL discourse community together, there was such a perfect dovetailing between the properties of these discussion moves that they were teaching teachers to do and forms of transactive exchange. Okay, now you're probably thinking to yourself, wow, this talk is not really focusing on analytics, but we're going to get there. We looked to see if we want to put these two communities of research together, what would happen then if we looked at how we can introduce support into a collaborative learning context using those accountable talk moves from the teacher discourse community? Will it increase transactivity in those collaborative groups, and will it increase learning? And over a series of studies within the context of that professional development effort, we did see positive impact on interaction and learning locally within those collaborative sessions, but we also saw how it supported the teacher professional development effort and how students coming into their classroom prepared with these collaborative exercises facilitated, in a way, a better interaction between them and their teacher. The teacher was better able to support their interaction with each other, and we saw more success on that front as well. In order to be able to do this, we have to be able to monitor those discussions. We can see where we can offer support to improve the interaction. And this is where we start to get into analytics and the message I want to leave you with in that space. Because a lot of work in analytics focuses on the math, on the algorithms that are used to be able to learn patterns in data. Not enough focus is on the representation of the data and understanding the data enough to know what should that representation be so that the algorithms can do their work. It's a partnership, and it requires the insight of the researchers. And it draws in expertise from multiple research communities that have looked at language for decades before the work in learning analytics began. We want to draw on that expertise and listen to those voices. And so the foundation of our approach to designing representations begins with psychology or other behavioral research fields that focus on interaction and focus on language, like linguistics or philosophy or sociology. But on my slide, I'll just list psychology as a stand-in because I mentioned to you that we're talking about transactivity, and it comes to us originally from the developmental psychology literature. We understand from that literature what these processes are and how they work at a psychological level. And then we can turn to the field of sociolinguistics that builds on these foundational behavioral fields and looks up close and in detail, often qualitatively, at how these processes are reflected through the language choices that people make when they're aware of the choices and even when they're not. If we understand something about those choices, we can use that knowledge to help us design representations for machine learning. But we also are aware of how hard it is to do that effectively, how context sensitive the choices actually are. It can lead to some discouragement. It can tell us why, under certain circumstances, we have not been successful. It gives us an idea of the challenges. And so again, not a solved problem, but building upon what we know, we can then layer our analytics technology. And then we can have some success at being able to get a hold of these important processes that point back to that DNA of what generates these valuable interactions for learning from students. So in our research over the past 8 years or so, we have a series of results in which we've taken machine learning technology and text mining technology and have used it to build models that can monitor collaborative interactions through language, many of those results focusing on the idea of transactivity. And when we think about the experimentation that's been done and what are those clues that we can find in language that help us to identify where transactive exchanges take place, we can draw from areas of linguistics to understand how rhetorical strategies work, but also from social psychology where we can even understand what are those features of how we talk that show mutual respect. Because remember, there's the social underpinnings. There's the social climate that provides an atmosphere in which these transactive encounters can take place. And we can draw from that when we try to find the clues that we would build into our models to be able to do the detection that we need to be able to do. I just want to mention, how many of you have heard of Erving Goffman before? You probably didn't expect to hear about Erving Goffman in this analytics talk, and yet I find his work fascinating and incredibly relevant because he talks about how it is that when people interact through language, they make choices intentionally to present themselves in a particular way, but there are also choices that are subconscious that give off things about ourselves that aren't part of what we're intentionally trying to project. And often the same kinds of features can be used in either way, and they confuse our models because how can we even separate them? Yeah, it's discouraging. It leads us to think, okay, well, where does that leave us in terms of our modeling? But it helps us to take a realistic look at where the challenges are. Now, in our work, identifying what some of these clues are, we see some basic linguistic features that have worked in terms of giving us some of those clues. Some of them having to do with level of abstractness even in the word choices that people make, because an abstract representation of an idea shows some level of cognitive processing. We can look for these clues in our discussion analysis, and we've applied this in some massive open online courses to the discussion forums to try to gauge what level of engagement with each other and with the material students are displaying. And we can see these indicators as weak indicators, if you will, but indicators of cognitive engagement, of showing motivation to continue in a course. And we see, and here's just an example of a survival analysis that shows that where we have seen these kinds of indicators as clues of transactive exchange between students and associated with learning in a classroom context, now we're looking to see how they show commitment to a course in the discussion forum. So this representation shows on the x-axis time since the beginning of a student's participation in a course, and on the y-axis we see probability that a student is still active in the course at the next time point. And this blue line shows the pattern of attrition over time that's very typical in MOOCs. And these other dotted lines are associated with time-varying factors that we measure at each time point to see how their presence or absence manipulates the probability of dropout by the next time point. So a shallower line indicates a reduction in dropout. So this red dotted line being shallower than the blue shows that there's a significant drop in probability of dropout at the next time point when we see these indicators. So we see when students are high on the indicators of this kind of intensive engagement with each other and with the material, we see stronger commitment to the course. And where they're low, we see a much steeper dropout curve. And we've looked at this over multiple courses, and it shows us, at least in a correlational sense, that these indicators tell us something about commitment. We already know from our classroom research that engaging with one another in this way is valuable for learning. What this raises as a question in our mind is also, if we encourage this interaction, will it have a positive impact also on commitment to a course? So in a massive open online course, actually in a series of 3 deployment studies that we've done so far, we've introduced these collaborative reflection activities as starting with optional activities for students, and in a more recent deployment study as actually a required part of the MOOC. And we've looked at how student participation in the collaborative chats then affected their commitment to the course. And what we've seen across 3 deployment studies consistently is that participation in these collaborative chats is associated with significantly lower dropout over time by the next time point, which is what these kinds of survival analyses measure. And in our most recent study, what we were able to do is actually separate out the effect of the choice to participate in the discussion from the effect of having had an interaction with a peer, because sometimes when students clicked to join a chat, they had a chat just with a conversational agent, and other times when they clicked to enter a chat for the collaborative chat, they would have an interaction with another student. And what we saw was that the effect of participating in a chat with the agent did not change the dropout curve over the average dropout curve, but participating in a chat with another student had a 70% reduction in dropout at the next time point. So it's not that 70% more students finished the course, but it slowed down the rate at which students were dropping out. That shows us that these collaborative reflection activities are powerful tools for building community, if you will, and commitment to a course. But we'd like to do even more than that. We'd like to be able to foster more substantial project-based learning, group learning, real interaction over time within a course. And there has been some effort to develop platforms for offering in MOOC courses this kind of intensive social engagement between students. The NovoEd platform in particular has been a forerunner in this area, and I've always loved to see that they're offering these courses, that they have sold themselves as the social MOOC. But it's because they've been forerunners in this area that we realize there are some serious problems that need to be solved in order to make this effective. So we were very fortunate to be able to analyze data from 2 early deployments on this platform. This was a project-based course. And on the final project that students turned in, they were graded. They got one of 3 grades, 0, 20, or 40. And you can see how the teams are distributed among these grades. And these are of the groups that actually completed the course. The bulk of the student teams got a 0 on their project. Slightly more of them got sort of half credit, and a very small group did very well on the project. And so we look to see, how can we support these teams better? What's going wrong? And again, we come back to the idea, what makes good collaboration? We want to see that intensive exchange of perspectives between students. And we weren't seeing good interactions within these teams. Most of the teams were not showing evidence of this intensive interaction from the beginning. And so it didn't seem to us that just actually supporting the collaboration was going to be enough in this case. Could we take this idea of transactivity and the role that it plays in order to motivate an intervention that can help us to form teams that are more effective? Again, it comes down to this idea of transactivity. What were the problems we saw? Students were having trouble finding appropriate teammates. They were expected to do this at the beginning of the course before they even knew each other. And so if we could watch them interacting in a whole class context first, they would have the opportunity in that context, in that interaction, to gain more exposure to students, especially to identify who they could interact with in a meaningful way regarding the course content. We also saw that the teams would lose critical mass from having started too soon in the course when dropout is at its peak, at the very beginning when people are shopping around. And if we give them the opportunity to have some intensive whole class engagement first, it also serves the purpose of delaying the time when students have to make a commitment to a team. Also, we found that students, once they got into their teams, lost contact with the community that could offer them some more support that might not be available within their small group. And to start out with some whole class engagement would foster those connections with the community that would then support the smaller teams and still be there for them. So we ran a series of studies in the Mechanical Turk environment. Mechanical Turk is a crowdsourcing environment, and it's possible to use this to kind of simulate a course and to do studies where you can manipulate how you set up teams and support teams to start to fine-tune an intervention that you might try then in a more realistic learning context. And in this context, we were working on a team task where students were supposed to develop a power plan. And so we trained each student in one of 4 types of energy so that they could form a team where there was different expertise to bring together. And in their task, what they were going to do is evaluate different plans that brought together the need for understanding these different energies, and that they would negotiate and come up with a proposal in the end. So we wanted to give the students the opportunity to interact with one another transactively. Then we would be able to look at who was having these kinds of transactive exchanges with one another, and we would use that as a basis for team formation, solving many of the problems that I mentioned. So it starts out with the students getting some individual instruction, and then they would come up with a simple plan, a simple power plan using only their expertise, which they then submitted to a discussion forum where the whole community would have the opportunity to interact with one another about the different plans that students submitted. We would then do an automated analysis of that discussion to identify transactive exchanges and use that as the basis for grouping the community into groups of 4, where every team would have a member from each one of the 4 kinds of expertise. And what we would do is try to make sure that students got with other students that they had shown transactive exchanges with. And then we would look at how those teams performed. So here, the students are all being asked to interact with one another in this community. And we're using the transactivity now as an indicator of who would have a better collaboration in a future task. We used another form of analytics here as well, a constraint satisfaction algorithm that could do the assignment of students to groups in such a way that across the whole set of assignments, the average level of exchange transactivity within the teams would be maximized. And then the students would come together in their teams, and again, we offered support in those chats using conversational agents to structure the activity, and then they would work together in a shared editor to develop their proposal. We ran a series of validation studies in Mechanical Turk. I'm just going to mention 2 of them here. One of them to check to see, was it beneficial to the student teams that they had before they got into their teams an interaction with the whole community. And so we set up a similar progression of tasks, but in the control condition, students would do that deliberation step that, that in our paradigm for grouping students would have been done in the whole community. But in the control condition, they showed their proposal to their team and had that interaction with their team. They used the same discussion forum, but the only people around was their team. So the progression of materials and tasks was the same, but they never had the experience of the interaction with the whole community. In the experimental condition, they did. But apart from this distinction, how that stage of deliberation over the individual task prior to the team task was conducted, there was no difference between the experimental and control condition. But after the students completed their task, we compared the level of knowledge integration between the proposals that came out of the groups that had the community engagement with the control condition. And we saw a positive effect of being exposed to that whole community engagement of 3 standard deviations. In a second experiment, we compared how we were assigning students to their teams. Here, in both conditions, students would have that whole community engagement. But in the control condition, we ignored transactivity when we did the team assignment, and in the experimental condition, we used it as a basis for the assignment to teams. And so even the control condition was identical to the experimental condition in the first study. In this case, the second study, we see yet another positive effect of the manipulation of, again, 3 standard deviations. In some subsequent studies, we've also been looking at different ways that we support the collaboration once the teams were formed. But here, in this talk, what I want to focus on really is the process of forming teams. What we see here is that students benefit from the engagement they have with their class, but we also see how important this DNA of collaboration is. It's not only about what's happening in a learning encounter, but it shows us something about how students can work together. And it makes sense because of the social underpinnings. If we can get a hold of this building block, then we can make a prediction about how students will work together and in a way that has cognitive benefits as well. We have recently completed a deployment study with the Smithsonian Institute in their Superheroes MOOC. I mentioned this earlier, where we took this paradigm for team formation and have integrated it with their course. So we have tested one way of doing that integration, and we're in the process of a second deployment study. And we're starting to look at the kinds of projects that are coming out of the teams. And it's very exciting to see how the different perspectives that students bring with them in this course, where they develop their own superhero or pick a superhero to understand from a historical perspective when they come together, how they enrich each other's understanding and challenge each other to think more creatively and more deeply about the work. So in conclusion, what I want to leave you with after this talk is that we want to look beyond the algorithms in our work on analytics. Of course, those algorithms, they're important and we need them, and they're what enable us to do this analytics work. But we want to dig into the social sciences, different areas of the social sciences that give us real insight into interaction and how that works. And that includes a very wide net, starting with developmental psychology, but also social psychology and cognitive psychology, obviously. But sociolinguistics, sociology, even philosophy, all of these areas come together to help us understand how complex and multifaceted and deep and fascinating interaction is. It scares us sometimes when we realize it's certainly not trivial. And yet we can find these things like the idea of transactivity that we can get a hold of. They're handles, and they help us to monitor something meaningful in interaction and also to design and deploy interventions that have a positive impact. We have this three-part pipeline that I referred to in the beginning. It starts with theory that gives us insight. It helps us to identify patterns, and the patterns trigger support and lead to results. I want to point you to what we're calling DANCE. It's an initiative at Carnegie Mellon University. It's a community building effort where what we'd like to do is really gather together an international community of stakeholders, not just researchers, but policymakers, developers, instructors, people who are thinking about the future of learning from their different perspectives. And we're offering resources, but we're also hosting discussions where we're thinking about how best can we make online learning a socially engaging experience for students so that we can leverage the powerful impact that those interactions can have. We offer tools. We offer a monthly online talk series. So come to our website, make use of these resources, and join in to our work. And thank you very much. And now I welcome your questions and critical comments.
Anyone, please.
Chi San from the Learning Sciences and Technologies Academic Group at NIE. Thank you for a most interesting talk. I appreciate where you're coming from, and from a CSCL point of view, I think this is really innovative work. I'd just like to share an idea in my reading in a very recent article by David Lundy. It points out that this information theoretic approach of learning analytics is fundamentally incommensurable with the notion of learning. And the reason for that is that learning from a human-oriented perspective is fundamentally phenomenological. So its presentation of the sense of learning document will be cited, rather than purely representational and computational. So I think this is an important point for the audience and the community to be aware of, that this is really a form of modeling. It is a model, and a model can go out of date, as pointed out by Pardo, and therefore we're very careful about the lifespan of these kinds of models that we make use of. But in terms of trying to foster the kind of accountable thought, I think this is what we do. Thank you.
Yeah, I'd just like to respond to that. I agree to some extent with that statement that learning is phenomenological. I think there are an incredibly large number of really important contextual factors. And of course, the literature on transfer of learning challenges the idea that there are generalizable patterns. And yet, we make use of the patterns that we find. They don't work for all of the students. I loved Shane's graph where he showed, well, here's where we were intervening, and it happened to work with students on two paths, but the ones we really care about, it was just a little bit too late. But on average, you could see a positive impact. And we know every time we draw a generalization that we are making mistakes at some level, that it's working on average, but we're missing things. And if we drill into the data more, we see those important interactions between variables. And the more interactions that we become aware of at the extreme, we would have to conclude that learning is phenomenological. And yet we have to be able to have some basis for decisions that get made. If we don't make some generalizations, our hands are tied when we try to make decisions about trying to improve the situation of learning for students. So if we don't want to give up and just take whatever may be attitude, if we want to have a data-driven way of making decisions about trying to improve the situation for our learners, we have to make some sacrifices we have to know that we're making some mistakes, that whatever principles we think that we have some foundation for, we know there are oversimplifications, but on average, they have a positive impact. On average, they point us in a direction that might lead to improvement. Other questions, comments? Oh, come on, somebody must disagree with me.
Anyone?
Jen's looking at me.
Oh, yes. Yes. All right, we'll come to you next.
Okay, fair enough.
Hello, hi, I'm Boon Singh from MOE. I'm very curious with the computer chat agent. When the student interact with the chat agent, how is the interaction like? I mean, do they know that this is a computer chat agent? Do the computer chat agent reply and react in the most human manner? And does it impact the learning?
Okay, there are lots of questions in there. We don't make any effort to convince students that those agents are human. In fact, we think it would be a mistake to try to convince them of that. Although in some prior work, what we found is if we can at least temporarily convince students that they're talking to a human, they respond completely differently to the same prompts that they're getting from the agent and even learn marginally more. But we don't expect that that effect would be long-lived, that it scales. And so we're not going that route. In a subsequent study, what we saw, though, was as soon as a student knows that it's not a human, it doesn't actually matter that much how human you make it behave. That the kinds of things that humans do that elicit more response or more listening don't work the same way when it's a computer agent. We actually were pleasantly surprised when we saw that the accountable talk moves, when implemented by a computer agent, still had an impact on the interaction between students. We were worried that that agent wouldn't have the kind of presence in the discussion that a human teacher has that allows their intervention to work. In that case, it worked. I certainly would not ever claim that the agents, as we've designed and implemented them, behave in the most human way. And yet, we have done a series of design studies in which we have tested principles of design and have seen how they influence how students interact with one another. And so we pick aspects of how they interact that we have some evidence leads to a positive effect.
Sure.
Yes.
So I guess, what if you separated out the transactivity within the realm of the conversation and had it like a post-activity summary, so that they're still answering the same prompts, but it's then outside of the context of the conversation or the discussion?
So what you're saying, if I understand you correctly, is what if the agent was not involved in the interaction between students, but instead allowed the students to interact, but then supported a reflection stage that would happen after the collaboration? Would that be equally effective? Is that what you're asking?
That's actually a better question than what I was asking. I was thinking of, like in a classroom setting, teacher has small group discussions and then makes them fill out a worksheet at the end, which is supposed to be the post-group discussion. These are the major key points. And so yours is more nuanced because it's picking up the things that haven't been mentioned inside of the group discussion. But is that going to have the same power, the same effect sizes, or would you suspect that it's within the flow of the conversation that this is important? So that goes back to the social dynamic.
Let's see. I think that there's been a lot of work on supporting self-explanation. That's a little bit like what you're suggesting, really. That at a certain point, a student by themselves gets some prompts that help them to build on reasoning that they've seen and draw inferences and think more deeply about the material. And based on the research that's been done in that space, I would expect that it would have the same effect on learning because it gives the student the opportunity to reflect and to be challenged in their thinking. In the interaction, however, what students gain is more than what happens just at that time. They learn how to use each other as a resource. And so if they never learn how to use each other as a resource, then they're alone in their learning. The hope is that the students gain some confidence that if they don't know something, they can work it out with somebody else. They don't need to just be told the answer. So they're gaining some skills that they can use in their interactions with people going forward. They're learning also how to interact with people who think differently from them and to be able to come to decisions together. And those skills are also important going forward. And so, without running the study, I can't really tell you what we would have seen in the exact studies that we did. I could see reasons to believe that some of the effects would transfer and some would not. I think that I like the idea that students are having this intensive interaction with one another, that we can support that intensive interaction and also that we can monitor it to use it in order to create better opportunities for them forward.
Thank you. Is there any other burning question? If not, I have one, and then we'll break for coffee. Does that sound good? It's been a while. Carolyn, earlier, building on Shane's work, the selection into groups and particular collaborative groups are more successful in their problem solving or their project-based learning. And that was selected based on transactivity.
Mm-hmm.
So would already higher motivated students building on their work that they cluster together, those that in like the top 10% or the lower performing students tend to cluster in their ego networks. Is there a possibility that those that are more transactive were already more motivated and therefore more successful? And if that was the case, would we be, from that form of logic, would we unconsciously be widening achievement gaps, perhaps? I'm not sure. That's
an excellent question, and in fact, I always get that question, and I think what that means is that I'm not explaining myself very clearly about how it actually works. Because when we do the transactivity-based matching, everyone in the whole group gets placed into one group or another, and what we're trying to do is maximize over the whole set of assignments what the average across the groups is in terms of the displayed transactive exchange from the discussion. So there are ways, so it's true that some students have contributed transactively more and some less, but it's also true that the same students interact differently depending upon who they're talking to. And that's why some assignments will lead to a higher average over the whole community, even though it's the same set of students. And so it's a matter of placing a student in a context in which they can perform the best. But it's still all of the same students. However, there is still a possibility that there could be a problem, and that is that students who perform poorly, it might not matter to this maximization algorithm where we place them. And yet it might matter a great deal to their experience as a learner in their groups, where they end up. It might be better to place, for these students anyway, to place them in a group that can support them. And that's a way I think we might be able to make it better. We haven't tested that explicitly, but it is something that's on our radar.
Yeah, great, thank you.